Good evening, everyone, and welcome to Glasgow Science Centre's Curious About Innovation Digital Science Festival. My name is Nina. I'm the Planetarium Coordinator here at Glasgow Science Centre, and I'm delighted to be joined by retired NASA astronaut Michael Baker. And for their support, we'd like to say a massive thank you to the University of Strathclyde for supporting this event. In just a second, you're going to hear from Michael, who's going to tell you a bit about what it's like to fly in a space shuttle, to live and work in space, and also show you a sneak peek of what Scotland looks like from orbit. After his talk, we'll be opening the digital floor to your questions. So if you want to ask an astronaut any of those burning questions that you've always wanted to ask, just pop those into the YouTube comments and we'll try and get through as many of them as possible. With that out the way, it's time for us to get started. So sit back, get comfortable and enjoy the talk. We'll see you in about 25 minutes.
Good evening, everyone. I got to say, I wish I was there in Scotland in person, but we'll have to accept this format for now, I guess, maybe next year. I'm here to tell you a lot about flying in space, being an astronaut in our International Space Station program, and our partnership. I'll talk a lot about our partnership with Russia. And I'm going to do that using my fourth and last mission, which was STS-81. And what you see on the screen is the patch from that mission. It's shaped like a Roman numeral 5 because it was the 5th docking mission with the Russian space station Mir. And I'm going to go back, and before I actually really jump into the presentation, I'm going to go back a little history because I think it's important to talk about this. Remember, in 1991, the Soviet Union broke up. At that particular time, the International Space Station program consisted of partners, including the United States, Canada, Japan, and the European Space Agency, which included probably 15 to 16 countries, including UK. And so after the Soviet Union broke up in around 1993, the partnership decided to invite Russia to join the ISS program. And I think that was probably one of the most important things that we ever did. And we'll talk some more about that as we go through the presentation. But when we, once they decided to join us, we came up with this idea of the Shuttle Mir program. And I think it was a great idea. I don't think we would have been successful in completing the construction of the International Space Station if we hadn't done this. So the idea was for us to get to know the Russians and for the Russians to get to know us. And like I said, I think it worked very well. We sent about 10 missions to the Russian space station. And I shouldn't know exactly how many crew members, but we had crew members on board continuously the Russian space station for about 2 years. And so our mission was to exchange crew members and to bring up cargo. And like I said, I'll talk more about that as we go along. So here's my crew. I was very fortunate to have a very experienced crew. That's me on the right. I always joke, I did have hair at one time. On the left is the Brent Jett. He was a Navy test pilot, just like I was before he became an astronaut. And then behind him on the left is John Grunsfeld, who was an astrophysicist before he became an astronaut. Next to him is John Blaha, who happens to be the commander on my very first space shuttle mission. And now he was the guy that was on the shuttle, on the space station Mir. And we were going to pick him up and bring him home. Next to him is Jeff Wyzoff, who's also an astrophysicist. And we have a lot of astrophysicists in the astronaut office for some reason. They're very smart folks. And then next to him is Jerry Lenninger, who is a Navy flight surgeon. He was the guy that we were bringing up to replace John on the station. And then on the right side, Marcia Ivins was a flight test engineer before she became an astronaut for NASA. So I had a great crew. I was very fortunate. There's two great things about flying in space, and there's of course more than that, I think, but one of them is looking at our beautiful planet. And I'll point out a couple of things here. I remember on my very first flight, when I first looked out the window, the thing that struck me the most was how deep, dark black this darkness of space, void of space is. It's just the deepest, darkest black I've ever seen. And then of course, the other thing that strikes you right away is how beautiful our planet is and how thin our atmosphere is. And how fragile our beautiful planet looks, and also how lonely we are out on this big black void of space. And just gives you this feeling, strong perspective, this feeling that we really need to take care of this place. and live peacefully together on it. And we'll talk a lot more about Earth observation as we go along as well. So on day 2 is when we got serious about rendezvousing with the Russian space station Mir, which is what you see here on the screen at about a mile away. And so this whole process of docking, rendezvousing and docking is very, very slow. It's almost like watching grass grow. But you can imagine when 2 vehicles that weigh about 200,000 pounds each are trying to rendezvous in close proximity to each other. So you want to do it very slowly. So this is a picture from inside the cockpit. That's me at the bottom down here, looking out the overhead window. And there's the station as we get closer. So here's again, as we get closer, and this right here in the center, you see this little orange circular thing here. That's the docking adapter. The docking adapter is something that we flew up on the very first space shuttle mission that went to the station. And that allows us to actually connect to the station. And there's other things you see. This is a Progress spacecraft, which we'll talk about later as well. And down here is a Soyuz spacecraft and the other modules. So this is what it looked like when we finally got docked to the station. This solar array panel right here was only about 3 feet away from the overhead window. Of course, these solar array panels collect energy from the sun and turn it into electricity to power the station. This is the main base block of the station. And right here you see a nice little portal. That's where the cosmonaut crew quarters is at. And later we'll see some pictures looking back at the space shuttle, which are pretty spectacular. Again, looking at our beautiful planet. This happens to be the west coast of South America, Chile. So it's the Pacific Ocean out here, and we're looking south down the Andes Mountains. And then again, how beautiful it is and how fragile our beautiful planet is. This is a picture of the Soyuz spacecraft, and I'll talk a little bit more about this because this is what the Russians used to get their crew members back and forth to the station. And if we didn't have the Russian partners, we probably would have lost the International Space Station back in 2003. And remember, in 2003, we had the Columbia accident on the space shuttle. And so we were unable to get our crew members to the space station. And fortunately, we had the Russians as partner, and we started using the Soyuz to get all of our crew members to the station and return them home safely. And then, of course, in 2011, we stopped flying the space shuttle completely. And so since 2011 until this year, basically, we have been depending on our Russian partners to get all of our crew members back and forth to the station. So it's very good that we had them on as partners. And now you probably heard about the commercial crew program. SpaceX has flown the Crew Dragon. We've flown astronauts to the station actually 3 times now. One just last Friday, I think, was the launch and docking on Saturday. And so that was the second crew that we sent up on the commercial SpaceX Crew Dragon. And then so now we have 2 redundant ways of getting people to the station. And we have, hopefully later this year, we'll have a 3rd one. Boeing is building what they call a CST-100 Starliner spacecraft, which will launch on a Atlas V rocket. And once we get that, we'll have 3 ways of getting to the station, which will be great for all of us. This is a shot looking back from that portal that I mentioned. At the space shuttle's nose, it's sitting on the horizon. It's a beautiful picture. It happens to be a cover of a book with Earth observations. You can see, again, a real thin atmosphere, beautiful planet. We happen to be over what we call the terminator on the Earth. Is the place on Earth where it goes from night to day. Nice lighting, beautiful dark black, deep dark black. Let me point out a few things on the shuttle that we see here. These holes or nozzles you see are reaction control jet nozzles, which we use for attitude control and translations. These are the forward windows. Right here on the far right are the overhead windows. This is a KU band antenna that we use for communications. And there's a couple of circles here that you see. Those are star trackers. We use those to align our inertial navigation system. After 3 days, we completed all of our transfers of cargo and crew members. And so we undocked and we backed away about to 150 to 200 feet. We performed 2 fly-arounds of the station, took lots of pictures. We sent all those pictures back to Moscow, and so the engineers could look at them and evaluate the condition, the exterior condition of the station. And this is kind of a neat picture. We'll take a little bit of time with this. Down at the bottom, you see the Soyuz spacecraft, which is the lifeboat, which we used to get up and down from the station. At the top is another spacecraft that looks like a Soyuz. That's the Progress. It's an unmanned cargo spacecraft, which they would use kind of, once they got it, they'd unpack it, and then they'd start using it as a trash can. And then once it got full, right before the next Progress would come up, they would undock it, and it would come back and burn up in the atmosphere. The other thing you see here is the orange docking adapter. So this is where the shuttle was actually attached or docked, and then the 4 modules around this node. So then after we've completed those 2 fly-arounds, we did a small burn with our reaction control jets, and that slowly started moving us away from the station. And so this is a series of pictures of us moving away from the station. You can see this nice blue color of the solar array panels. Sometimes they were blue, sometimes they were gold, depending on the angle of reflection of the light. Getting just further and further away, this is kind of a neat picture now with the station on the horizon. And this one is actually one of my favorite photos. You can see the station. We're directly overhead the station, and the station, we are directly overhead this island, which is the country of New Zealand. And you can see these glaciers and glacial lakes down here at the bottom. Very beautiful. So this is a picture of me with a big, large format camera in my hand. There's another camera you can see here. We had cameras located all around the cabin, around the windows with Velcro, so that we would be ready anytime to take pictures of things out the window, which is probably one of the favorite pastimes of most astronauts. So I'm probably like 100% of them. And so I'm going to talk a little bit more and show you some pictures of the Earth now. This is the other thing that I got to remind myself too is to try to tell you that we use a lot of different lenses. You know, the 50mm lens is the standard lens on a camera, and gives you kind of a view or a photo that shows you what it looks like to the naked eye. And we use the 100mm lens quite often to get more close-ups, and sometimes we use a 300mm lens. This happens to be a 300mm lens looking way out at the horizon. And look, you could almost think this was taken from a commercial airliner, but it wasn't. These are big thunderstorms out on the horizon. You can see beautiful atmosphere. And what we're looking at is a sunset. And this is kind of neat too. I think, since we're going 5 miles a second, we go around the Earth every 90 minutes, which means every 45 minutes, we're getting either a sunrise or a sunset, and they're absolutely gorgeous. And that's another great thing about flying in space as well. This is a great thing that we got to see on my 3rd flight. Actually, this was just erupted, and we were almost probably the first people to see it. And it was just after our launch. It was really spectacular. It's the Kluchevskoye volcano in the far eastern part of Russia on the Kamchatka Peninsula, which is around the Ring of Fire in the Pacific Ocean, has lots of volcanoes. So you got to see the main volcano here erupting, and a couple of smaller volcanoes next to it, which also have some smoke coming out of them. You can see some lava flows down the side of the mountains. And then you can see all these other volcanic cones around here. So this area of the world has lots and lots of volcanoes. So this is California. This is where I grew up. And so I like to take pictures of California. It's a beautiful state. And also, this is the big Central Valley of California. And I grew up right in here. These snow-covered mountains you see are the Sierra Nevada mountains, which is where Mount Whitney is, which is the highest point in the continental United States at about 14,500 feet. Down here at the top of the picture, this down here at the bottom of the picture is north looking south. And so this gray area, triangular area you see here is where the dry lake beds are at Edwards Air Force Base, which is where we sometimes landed the Space Shuttle. And this right over the mountains there is Los Angeles. It's another volcano, and I show this for several reasons. I like volcanoes, but this is Mount Vesuvius in Italy, taken just with regular visual photography. And I just want to point out that sometimes we use different imaging methods to look and find different things on the Earth that are important to us. So this next picture was taken with the infrared film, and you can really make out the structure of the volcano a lot better. And the other thing that this tells you is it tells you a lot about vegetation, because the darker the red, the more vegetation there is on the ground. So there's different ways to look at the Earth. This is just a neat picture too. Right in the very center of this picture is Mount Everest, which is the tallest place on our planet Earth. And you can see all these ribbons of glaciers that are in the Himalaya mountains. This is a picture of Houston. It's not the best picture, I always say, but I use this to help to start talking about training, how the astronauts train to go on a mission on the International Space Station. And it's a lot of training. It's about 2 years of training, and it's a lot of time away from home. So they spend about half of their time here in Houston at the Johnson Space Center, which is, this is Galveston Bay, this is Galveston Island, and right here is like downtown Houston, and Johnson Space Center is right here, down here on Clear Lake. They spend the other half of their time in Moscow at the Gagarin Cosmic Training Center in Star City. So this is a picture of Moscow from space. Actually looks a lot like Paris, in my way of thinking. At the very top of this curve in the Moscow River bend is the Kremlin and the Red Square. You can see lots of airports. There's one up here in the top left, that's Sheremetyevo International Airport. There's another one down here, a smaller one. And there's a really big one up here on the top right. That's Chkalovsky. It's a Russian Air Force base. And just outside of there, there's a group of buildings that you can make out. That's the Gagarin Cosmonaut Training Center. So it's just outside of Moscow. And, you know, they also spend about, you know, some time, not as much as they do in Moscow, but time in Europe, learning about the European module, and time in Japan, learning about the the Japanese module, and some time in Canada, learning about the Canadian arm. I show this for several reasons. This is the Aral Sea, but it's out in the middle of Asia, in Kazakhstan. Out here at the very top right of this photo is Baikonur Cosmodrome, which is where the Russians have their launch site, and where all of their crew members are launched from there to get to the International Space Station. And this is a picture of Florida here. This is the Florida Keys. And on the east coast of Florida, right about there, about halfway up the state, is where Kennedy Space Center is. And that's where we launch our astronauts from. This big island you see in the foreground is Cuba. And this nice blue water and islands you see over here are the Bahamas. It's the most beautiful place, I think, from orbit. It's really cool to see that beautiful blues. So now I can, you know, since I have an audience in Scotland, I had to show some pictures of Scotland from space. So I think we'll spend some time with this, and we'll talk a little bit about this. I think partly it's a little funny. It's hard to get, I'll tell you why it's hard to get pictures of Scotland from space. And one of them you guys are probably fully aware of, that it's cloudy a lot, so it's hard, but this is a nice clear day in Scotland. The other thing is you're so far north, you know, I think Glasgow is around 57 degrees north latitude. And this will give you a little orbital mechanics lesson. So normally what happens is when we like to launch due east from our launch site. So we'll just use Kennedy Space Center as an example. It's at 28.5 degrees north latitude. If you launch due east from there, you end up in an orbit that's inclined to the equator 28.5 degrees. So you're going around the Earth like this. Up here, you're 28.5 degrees north latitude, and down here, 28.5 degrees south latitude. Now, if you want to go, so that if you think about that you don't see or overfly much of the Earth. In fact, 28.5, you overfly a little bit of Florida and a little bit of Texas, and so you don't even overfly the United States. You don't overfly Europe, because 28.5 degrees north latitude is somewhere in North Africa. So if you want to fly at a higher inclination and include other, ground, fly over the more bigger portion of the Earth, you have to go to higher inclination. And we do that by launching kind of north up along the east coast of the United States. And then when we get to where we want to go, we kind of start heading east, and we'll end up in an orbit that's inclined at higher. So the space station, well, let me go back up a little bit. The shuttle, we flew on my third mission, we flew at a 57-degree inclination. So we saw a lot of the Earth that way. And then, the space station's at 51.6 or 51.5, something like that inclination. So it doesn't fly over Scotland either. but you can see Scotland at an angle out the window. So that's another reason why it's difficult to get pictures of Scotland. But this is a great picture. And, you know, you have to learn a little bit about geography if you want to find places, because you don't really see any cities, right? But so the thing that I'll point out here is this is Loch Lomond. It's got a very distinct shape, so it's easy to find. And of course, this island here is Aran Island. It's easy to find as well. And the Mole of Kintyre, all these are nice things that you can pick out and help find your way. So that helps you lead right up here to the Forth of Clyde and the Clyde River. And then that takes you down to Glasgow. So there's Glasgow. Let me go through some, there's just another close-up of the nice pretty picture of Aran Island and the Mole of Kintyre. And here's another picture. You can see it's harder to pick out things. It's a little bit more cloudy, but you can still easily see Loch Lomond, which is right there. And so there you can see the Firth of Clyde. There's Aran Island, excuse me, Aran Island's here. So this is a neat picture because you can see all the way across Scotland. So up here, you can see all the way up here to the Firth of Forth, which I love to say. And so right in there is Edinburgh. You can even see, whoops, let me back up. Over here is Fife, of course, and then Dundee over here. So pretty neat. And this is a very, very far north of Scotland, which I think everybody can pick out. These islands here, the Orkney Islands and the Shetland Islands over here to the right, John O'Groats. And I forgot the Cromarty Forth or something like that, Inverness over there, and even Aberdeen right here at the very bottom of middle of the screen. Anyway, so now this everything good thing must come to an end. This is this is a mid-deck, what it looked like when we were getting ready to do our Deorbit Burn to come back home and land at the Kennedy Space Center. So what you see here is these orange launch and entry suits. These brown bags contain our parachutes and our helmets. So this was, I think this is Marcia Ivins here. You can barely see that there's a person there, but she's getting everything ready for us to jump into our suits and back into our seats so that we can perform the entry. And I'll talk, the entry, the Deorbit Burn and stuff is always amazing to me. Remember, we're going 5 miles a second, 17,500 miles per hour, and we're weighing about 200,000 pounds. It's a lot of energy to get rid of. So somewhere over Australia, actually, we do a deorbit burn. So we turn the shuttle around and put the engines, the orbital maneuvering system engines in the velocity vector, and we fire them off for about 4 minutes, and that slows us down. And when you slow down, you start to fall out of orbit. And so for the first 30 minutes of our entry, we're just free falling in space, basically. And then we hit the atmosphere. It's the whole entry is very, very smooth. When you hit the atmosphere, you start to decelerate some more, but it's very, very slow deceleration. And it picks up a little bit more as you go. So the next 30 minutes, you're decelerating. And once you decelerate below Mach 1, you happen to be about 50,000 feet overhead your landing field. And then we took over manually and flew a 20-degree dive angle, basically around a heading alignment cone or circle that allowed us to line up with the runway. And we flew that at 300 knots, 20-degree dive angle. Once we're lined up on the runway and we passing through 2,000 feet, we performed a pre-flare maneuver, which reduced our glide angle from 20 to about 3 degrees, which is what a normal commercial aircraft would see or use for a landing. And we continue our deceleration and descent. And as we pass through 400 feet, we lower the landing gear and continue deceleration, touch down about 195 knots on the end of the runway, which is very fast, by the way. Most commercial airliners will touch down around 125 knots. So, you know, it's almost 70 knots faster. And then we would lower the nose and extend the drag chute and come to a stop on the runway. And that would be the end of our mission. Well, not completely, because then we'd have to go through some medical checks and medical experiments and things for another few weeks. But that's the end of my presentation. I think I've taken enough of your time, and I'll be happy to take some questions. Thank you very much.
I really do hope you enjoyed Michael's talk. I know I did. I could look at some of those pictures from space for hours. But the good news is we're not going to make you do that. We're actually going to bring the man himself. We're going to be joined by Michael, a retired astronaut, who's here to answer some of your questions. If anyone's thinking of applying to be a European Space Agency astronaut, the applications are open, so this might be the time to get some top tips. Thank you so much for joining us tonight, Michael.
Thank you for having me. It's great to be here. Wish I was actually there with you, but this is the second best thing, I guess.
And indeed with the rugby top here with us in spirit. So we've already had a few questions in from YouTube, and I quite like this one to start off with. Owen, who's 8, has asked, what is the best bit about being an astronaut?
Well, there's a lot of good things about being an astronaut, but of course, I guess the best one is being able to fly in space. And what I always say too, the best part about flying in space is being able to see our beautiful planet from orbit. And it's just an amazing, awesome sight. And it's something that you'd never get tired of looking at. So yeah, flying in space is the best part about being an astronaut, no doubt.
I think that's probably what everyone was kind of hoping to hear. I think we've got another couple of questions coming in. Our lovely producer Stephen is sending them over for us. There we go. So Derek Charlotte has asked, you've been lucky enough to see much of Earth from space. Are there places or features you haven't seen on the planet from space that you wish you could have firsthand?
Yeah, there's lots of places that I didn't get to see. And kind of like we talked about, we only fly up to 57 degrees inclination. So there are some parts of the Earth that we didn't get to see. And a lot of different features, because each flight is a little bit different. You see, you fly over different places at different times of the day. And, when you're sleeping, maybe you miss some things. One of my flights, actually one of my favorite flights was because our job was kind of looking out the window and taking pictures of the Earth with the space radar laboratory. We were taking pictures of what the radar was looking at. Anyway, and we had two shifts. So some of us, were operating for 12 hours and we slept, and the other part of the crew was operating for 12 hours. So we basically missed half the Earth unless we wanted to stay up all night. So, but yeah, it's just so much to see and so much to enjoy.
Have you got any, other than seeing kind of California and where you were born, is there any kind of real highlights that just stood out more than anything for you?
Well, it's great to see everything, all the places that you see that you want to see, and a lot of places that I haven't been to on Earth, which I would love to do.
Adding to the list.
Yeah. Some of the, one of those particular things is the aurora. I have not seen the aurora from Earth, but I've seen it from space, and it's really quite spectacular. Gosh. So that's on my bucket list, I guess, is to try to go see it from the Earth.
I've seen it once from a plane, and it was incredibly faint, but it was still pretty spectacular.
Yes.
I think we've got another couple of questions coming in. There we go. So Space Shuttle was the iconic spacecraft for me growing up, and even now as an adult. So you got to fly in the shuttle not once, but 4 times. So what was it like to launch aboard the shuttle?
Well, I have to agree, the Space Shuttle was quite an amazing flying machine. It was flying like an airplane, like a spacecraft. You could take up, thousands of pounds of cargo and large items and do all sorts of things with it. And unfortunately, we don't have it anymore. Being able to launch, it was incredible. I think I talked about it in my talk a little bit. But yeah, it's quite a kick. When they light the solid rocket motors and you jump off the launch pad, I said at 2.5 times the acceleration of gravity, and it's a lot of vibration. It's just a whole lot of vibration during that first 2 minutes, and then it got really smooth. And it's just an awesome experience. And I really, that's one thing I think I mentioned in my talk too, that I'm looking forward to more people being able to fly in space and to experience this, this great thing and get this perspective of our Earth. And I think that's going to be wonderful for a lot of people.
I think so. I think is it called the overview effect?
Yes.
It's something that's kind of unique to astronauts. It's something that only a very select few people actually get to see. Actually, talking about the kind of new ways to get into space. So as you mentioned in your talk, there's going to be 3 in operation in the next sort of year or so. So we've still got the Soyuz Crew Dragon's in operation, and soon there's going to be the Starliner. They're all quite different spacecraft. So is there one that you would particularly like to fly in, to get the chance to go in?
It's been pretty exciting to watch the Crew Dragon from SpaceX. It's so futuristic, I guess you could say.
It looks like something out of Star Trek.
It almost looks, it's just like driving your car with the big screen TV up in front of you, and there's nothing else there. So it's very cool. I would love to fly that.
They do. What about the uniforms that they have to wear, the pressure suits?
Oh yeah, those are much nicer looking too than the ones we used on the shuttle, aren't they?
I don't know. I think there's something about that international orange suit that, again, I think it's just because the shuttle's a real icon for me.
I haven't actually heard too much about the new suit, but I think it's much more comfortable as well. The orange launch and entry suit was very, very uncomfortable.
I can imagine.
Yeah.
Let's see.
Soyuz is extremely cramped. That's the other thing. I mean, I don't, they sit in their chairs with their knees up, crammed up towards their chins, and it's very, very uncomfortable too. So there's not much space in the Soyuz, but the Crew Dragon has quite a bit more space.
Yeah, there's a bit more room. I think, is it Paolo Nespoli? He's the Italian astronaut, and I think he's about the tallest you can be and still fit into a Soyuz, and he really does look like he's squashed in there.
Yes, he's definitely squashed in. He's a pretty big guy.
Yeah, I feel like as a tall person, I wouldn't fit in a Soyuz either. I think maybe got another question coming in. There we go. What does it feel like flying through space in the space shuttle? So once you're actually in space and the vibrations have stopped, the kick stopped, what's it actually like to be in space in the space shuttle?
That's a good question. It's really very comfortable, actually. It's very serene, actually, and quiet. Well, it's not really quiet because there's lots of noise inside the cabin. There's a lot of fan noise, like being on a ship or something. But in fact, we have to warn people that we're going to shut off the main cabin fan when we're doing some house cleaning, because everything gets really, really quiet then. But basically, when you're looking out the window, everything just seems so comfortable and so serene and peaceful. And then you remind yourself that you're going 5 miles a second, and at some point you're going to have to come home, But otherwise, it just feels great. And then inside the cabin, there's very, very comfortable temperatures. You're in, short sleeves and shorts, and it's very nice, very comfortable.
Someone's pointed out on YouTube, BOK has pointed out that it is indeed hard to see Scotland, not just due to clouds, but due to lots of rain as well.
Yes.
You must have seen that.
That part of Europe in general, it's cloudy a lot, it seems like.
The photos of the thunderstorms were still pretty spectacular, so I suppose there's always a silver lining to it.
Mm-hmm. That's true.
I think, here we go, got another one. Oh, that's quite a good one. So Orla has asked, where do you think the next big developments in space travel will take us? The moon, Mars, or somewhere else?
Well, that's a good question too. But we're headed back to the moon. At least that's what we hope we're doing, and I think we're going to be heading to Mars too after that, unless Elon Musk and SpaceX beats us to it, because I think they're ready to go to Mars directly. They're working on that, but I think. I hope our partnership, international partnership, was going to go back to the moon soon.
Yeah, I think the European Space Agency and the UK are part of the Lunar Gateway. I think we actually had Miriam Sargising of NASA on last night talking about that.
Yeah, that's a pretty neat thing too, I think.
It's really exciting. There we go. I think we've got another wee question coming in. Stephen's going to bring that up. BOK has asked, did you ever see any UFOs?
No, I never have. There sure is a lot to talk about that nowadays, isn't there? But I haven't.
Pretty recently, actually.
Yes. Yeah, because I guess the U.S. government has released a lot of that information. So, and that's about all I know about it. So I haven't really seen any myself, no.
No, just identified flying objects.
Yes.
Cool. I think another one. Orla's got some good questions tonight. Thank you. So what was the most exciting thing to see when looking away from Earth out into space? So looking out into the opposite direction.
Well, it's pretty amazing how many stars are out there. But, at least for me, most of the time, I didn't look out at the stars too much. I looked at the Earth. But so besides the stars, in fact, I talk about that. I think going to Mars is going to be very difficult because, for one thing, it's a long trip, and the other thing that instead of being able to look at the Earth as you're going on your way towards Mars, all you're going to see is a bunch of stars, which I think kind of looks the same all the time. And so I think that's going to be kind of tough on people that are going to be going to Mars.
Just losing sight of home.
It's really incredible to see the stars like that. But it's also really true. If you get up on a high mountaintop on Earth on a clear night, it's about the same view that you're going to get from the shuttle. Because, like I remind people, we're only a couple hundred miles closer to the stars than you are on Earth.
That's always a nice thing to remember, I think.
Yes.
Although I believe you get to see the stars not twinkling because you're above the atmosphere. That's the big difference.
True. That's true.
That must be quite unique. There we go. So I think there we go. So you were on Mir for a little while, which was the sort of predecessor to the International Space Station, but it was quite an international space station in itself. So working with crews of different nationalities, did this raise any challenges when you were on board, or did things run fairly smoothly?
No, everything went great. In fact, I think that's the beauty of the International Space Station as well, is it's a multinational, and bringing all these countries together and being able to work with people from all over the world is just a lot of fun. And you can tell it brings us all together, and it's very nice. So no, we had a whole lot of fun going to Mir. I always tell a story about Valery. Valery, the Russians are so hospitable. They when I'd come over there to the Mir from the space shuttle, he would say, Michael, come over here, have some tea, have some coffee, have some food, whatever you want. And we really had a good time. And we had some unusual times too, because they had just received a Progress spacecraft when we were on board, and they had a lot of fresh food, and they had like a big chunk of cheese. It was probably like 10 inches long and 4 inches square. And I remember him bringing out a butcher knife, which we would have never allowed on the space shuttle, but they were using that to cut the cheese, and so we shared some of their fresh food. And I told them they shouldn't do that because, we're going to go home in about 3 or 4 days and we'll have all the fresh food that we want. But you guys really will be here another month or so. So anyway, it was fun. It was fun.
Sort of gives you a whole new perspective on the food that you eat in space as well, because you'd imagine it's a lot of packets and things like that rather than a kind of whole wheel of cheese.
Generally not very good. I get that question a lot too. I mean, it's been about 24 years, I guess, which I hate to say, since my last flight, but I'm hoping that the food has improved. I think it probably has.
I believe Heston Blumenthal was involved actually in, he's a sort of gourmet chef. He was involved in Tim Peake's food, so Tim Peake got to have like bacon sandwiches and things like that on board the space station.
A lot of, especially the Europeans, are bringing those sorts of things to the station. I think from all in the Japanese are bringing a lot of their own food too. So I think that was probably fun. I didn't get to experience any of that, but I'm sure that was fun.
That's actually quite a good question. Which of the international partners do you think brings the best food into space?
That's a good question. I don't really know. I would guess the French.
I know, and they've actually got a French crew member on board, Thomas Pesquet, so he must be having quite a nice time.
Or maybe the Italians, who knows? I think the Italians brought coffee.
Yes, they brought I think it was the first proper espresso machine to the space station. That was quite a big deal. I think we've got a couple more questions. Oh, there we go. So Finn, who is 6, would like to know what you do all day while you're in space.
Oh, good question. There's lots of work to do, especially on a shuttle mission, because it's a week long. Every minute of your day is scheduled with something. You wake up, just a typical day, you wake up, you clean up like you would on Earth, you have some breakfast, and then you start working. And you do all sorts of things, experiments, house cleaning, keeping the shuttle clean and neat, lots of experiments, deploying satellites, doing extravehicular, EVAs, spacewalks, and you don't have a whole lot of free time. So, and then when you get a chance, you take pictures out the window. So you're busy constantly.
It sounds like taking pictures out the window during your free time sounds like a very good use of that free time.
Yes, that's true.
Let's see. Oh, Haley has asked, what does the moon look like up close? So I don't think you were, as you said, you weren't that far from Earth, but
no, it
did you get
looked
to see it from
basically the
space?
same. Yeah, basically the same as you would see it from Earth. But it's really spectacular to see it rise quickly, as you're going around the Earth. And as I mentioned, sunsets and sunrises are spectacular too. And you get them every 45 minutes, which is still, it's just an incredible thing. I love them, and it's nice to get them every 45 minutes.
You don't have to wait like the rest of us.
Right.
Let's see. Got any more questions? I think they're sticking with the theme of the food. So Owen, who is 8, would like to ask, what did you have for dinner when you came home from space?
That's a good question too. I don't really remember, but it seems like I probably had pizza before, hamburgers, things like that.
I quite like that. So we've got about 5 minutes left, so enough time for a couple more questions.
Okay.
Oh, there we go. So lots of kids, and I think some grown-ups as well, dream of being an astronaut. So which bits of your job were exactly the way a young person would imagine, and which bits were completely different from what you'd expect?
Well, I can say kind of jokingly, but they didn't tell you up front that you were going to be doing all this public speaking, which we do a lot of, and which is also fine, but that's not something that was really expected, I guess, at least by me anyway. But and the other thing that I always like to talk about too is, I spent I guess 35 years as an astronaut, and I flew in space 4 times or 40 days. So there's a lot of time spent not flying in space, and so you have to enjoy what you're doing. And for me that was great too, because we got to fly T-38 aircraft, and as a pilot and test pilot, so I kept up my skills there. And yeah, so it's a lot of fun. You meet a lot of different people. You study a lot of different things and learn a lot of new things and subject areas that you maybe didn't think you would have. We learned, public speaking. We learned about high-speed aerodynamics. We learned about geology, meteorology, oceanography, all sorts of things that you didn't necessarily expect either. But besides learning about all the technical things with the shuttle, and of course all the science that you're doing on board too, you learn all sorts of different things. So that part of it was really nice. That
sounds really cool, and it's nice to know that sort of people who have lots of different skills can become astronauts as well in the same kind of vein. I think we've maybe got time for one more question. There we go. Orla, have you been to Scotland since you saw it from space?
Yes, I have. I feel very fortunate. I don't remember when the Scottish Space School started, but I've been kind of associated from the beginning, I think somewhere around 1995. And I've been to Scotland many times, talking to kids throughout Scotland, schools mainly. And because of that, I've been almost all over Scotland. I've been to Shetland, not to Shetland, I've been to Orkney Islands, I've been to Harris, and it's just been great to see Scotland. You guys really are lucky to have such a beautiful place to live in.
Yeah,
but unfortunately, I guess I was there, I don't remember last, it must have been 2019, in September or something like that in 2019. We talked to some schools in Glasgow.
Well, we'll hopefully welcome you back, and I certainly won't start any fights by asking you which bit of Scotland was your favourite.
Well, we always kind of home based in Glasgow, which was always fun. We enjoyed it. We stayed in the Millennium Hotel on George Square, which was always quite a nice place to stay. I guess it's kind of changed now. I think they rebuilt the station, right?
Yes.
They were in the process of rebuilding it.
You'll have to come back and see it at some point. So have we got time for one more question coming in? And go. Well, that's quite a big question. Has living and working in space influenced how you live on Earth? That's one to finish on.
I think you're just much more aware of this, of how fragile our planet is and how important it is for all of us to live here peacefully and take care of it, you know. And so I think that kind of ideas has really influenced, you know, the way we live and the way we try to pass on our experience to other people so that everybody can kind of do the same thing. So.
And I think our audience is really grateful for that.
Mm-hmm.
I think that is us out of time. So I do want to say just a massive thank you for joining us. I know that public speaking wasn't something you were expecting to do when you signed up to be an astronaut, but we really do appreciate your taking the time to join us today. That is us for the evening, but there's a whole day of Curious About Innovation happening tomorrow. So do get stuck into that. But for now, it's just for me to say thank you to all of you for joining us and goodbye.
It was great. Thank you very much, Nina.
Thank you.
Good evening.